Hey there guys, in this video we're looking at area. So this is a review and recap of things that you might have done already in area. We're just looking at 2D plane shapes and also when we look at composite shapes. So area is the amount of space that is given in a figure. So that's denoted by units squared or centimeters squared. There's a little typo there. So it doesn't matter. People use feet, inches, but we're looking at a space where it is 2 dimensions. That's why it's called area. A formula is a shortcut for calculating this given area space. Now, if we really wanted to, we could draw a shape, say a square, and then overlay grid paper onto it, and then count up those little squares. And that is the same thing as working out area. Now, that after a while can be pretty tedious, especially if you're doing things like houses or tiling or like real life things or like a football field. So you're not going to lay down there and like measure out a meter square every time. So we use formulas as a shortcut. That's what essentially they are. So here you go. This is the formula sheet that would be given to you. So it's just important to know like what each part is representing. So things like circumference of a circle. So that's to do with perimeter. But the area of any parallelogram is base times height, which is length times width for a rectangle, or side squared, which is length. Circle, area equals pi r squared. A trapezium, so the average of the two sides multiplied by the height of the shape. And half of the base, because essentially a triangle is half of a parallelogram with the same dimensions. So those are what you need to do, or be aware of. Now, you're not going to, yes, we're not expecting you to commit them to memory. However, we are expecting you to be able to utilize them and also adapt them for, say, things like composite shapes. So here we go, finding area of basic shapes. So using our formulas from our QCAA. So identify the shape, identify the appropriate formula. Now, here we go. So area equals, so it's a triangle. So A equals BH over 2. Substitute in, there's our base, 4, 6, 2, 12, check your units, centimeters squared. Now in this case here, even if you were to, say, forget the area of a trapezium, generally you can break this down into a composite shape. So find the area of this rectangle plus the area of this triangle. But we know the area formula, so area equals half of A plus B times H. So as you see, it's up here. And then we're going to put that in. So, sorry, when I say put that in, substitute our values in. So 6 plus 10 times 4. And that's going to give us, half of that is 8 times 4, which is 32 millimeters squared. A equals pi r squared. Substitute in. So pi stays the same. Radius is going to be 7 centimeters. And A equals, now I'm going to have to do that on my calculator. And while I'm doing that, just remember, if a circle is given to you with a circumference, you will need to divide that by 2 to give you your radius. 7 squared. And okay, there we go. And that's going to give us, 153.93 93 and 154 centimeters squared. Cool. So that is plane shapes. That's just a recap. Now looking at composite shapes. Now you can either do this by additive, so breaking it down into 2 smaller pieces and then joining them together, or you can do it through subtractive methods, so finding like a big whole pieces. So the good old example for that one would be if you have like an L-shaped configuration, and you would find the area of this big shape and then subtract, so you would call that a minus A2, and that would give you this total area. So that is one way, or you could have it as, so if this was your L shape, A1, A2. And it doesn't matter which way you do your calculations, as long as you show you're working out along the way. So in this case here, I would use additive. That's just preferred for me because I can see that this is half a circle, so I'm going to call that A1, and this is a triangle, A2. So to find A1, I'm going to pi r squared and then divide that by 2. So I'm going to put that straight away into my formulas. A1 equals pi half of 6. There we go. See, 6 is the diameter, so 3 squared over 2, and that gives us, I'm just going to do that in a moment, and then the other one is going to be A2 equals base height over 2. Substitute my values in, 6, 7 over 2, and that is going to give us half of 42, which then gives us 21. Okay, so that's 21 centimeters squared, and then this one here is going to be 14.137 centimeters squared. Now total area equals A1 plus A2. Substitute in, 137 plus 21, which gives us a total of 35.137, and say we round to the nearest whole number, 35 centimeters squared. So that's our TA. Okay, this one here, so this would be a perfect example of using subtractive method. So I'm going to call this whole blue shaded area A1, and then this one here my triangle. So A1 equals pi r squared, because it's a circle and it's semi, so it means half. So A1 equals pi half of this, because it's the radius, 2.5 squared divided by 2 gives us an answer. And then A2 equals base height divided by 2, and that is going to give us, now don't be fooled here, it's nothing to do with this 5, you can use 3 and 4. So 3 times 4 divided by 2, that gives us 12 divided by 2 is 6 centimeters squared. Then it'll be TA equals A1 plus A2. Substitute in, don't know what that is yet, and 6, which gives us TA. So that's going to be pi times 2.5 squared and divided by 2 gives us 9.817. Add those together. 15.817 centimeters squared. Oh, and then if we round to the nearest whole number, that's 16 centimeters squared. Okay, there we are. This one here, so maybe have a go of that. Or actually, I'll show you, because this is another application of your composite shapes. So circles, you'll be given lots of different opportunities to use like a half, which you've seen a couple of times. This is a quarter of a circle, so you're going to take that formula, divide by 4. Now, if you get given a sector of a circle, that means that you're going to be looking at however many degrees it is divided by 360. So we'll have a look at that. So here we go. I'm going to call this A1, A2. A1 equals length width. That is going to be, yep. All right. Before we go any further, I'm going to go back here because I was just like, yeah, willy-nilly going for gold. What we can see here is that this is 8 and this whole length is 17. Now, if you have a look here, this is going to be 8 as well, which means that this length between here and here is 8 centimeters, which means the length of our rectangle is going to be 17 minus 8, which is 9. So it's going to be 9 times 8, which equals 72. Yes, I did that on my fingers. No, you didn't see it. Centimeters squared. Then we're going to do our A2, which equals pi r squared divided by 4. Now, if I was say, like, well, I know that that's 90 degrees there. If I have a look, 90 degrees, 360, if I simplify that, that's going to give us 1/4. So that's where that 4 comes from, as well as we know it's a quarter. A2 equals, substituting pi 8 squared divided by 4, and A2 equals, so plus A2, substituting in 72 plus, which gives us TA. So here we go, pi times 8 squared, divided by 4, this gives us 50.265, and then adding that over here, gives us 122.265, which to the nearest whole centimeter squared is going to give us 122 centimeters squared. So here we go, composite shapes, a review, and hopefully you'll be able to remember those skills from previous years. Okay, thanks guys, bye.